Good day everyone, this is Decadetya Enrico, and today I am going to show to you on how to calculate for the true bearing and gyrocompass error using the ABC tables. So I have here the three scenarios. The first scenario is position latitude north 10 degrees 19.0 minutes and longitude east 123 degrees 53.0 minutes in January 11, 2017. So local time or ship's time is 16 hours 18 minutes 25 seconds. The zone description is +8, so it is on the east, as you can see in the longitude, east of GMT. So you took the sun's bearing by gyrocompass. Observe bearing reads 243 degrees true. Calculate for the true bearing and gyrocompass error using ABC table. So this is the table. Just focus on this part. So to calculate, we need first the date, which is January 11 of January 2017. So to get the GMT time, because we have here the local time 16 hours 18 minutes 25 seconds, zone description is +8, so east of the GMT, so ahead of 8 hours. So to get the GMT time, the local time is given, which is 16 hours 18 minutes 25 seconds and in January 11, 2017. So since the zone description is +8 ahead of the GMT, so to get the GMT we need to subtract this 8 hours 00 minutes 00 seconds to the local time to get the GMT. So I have here 16 hours 18 minutes 25 seconds subtracted to 8 hours 00 minutes 00 seconds. So we have here the GMT time, which is 08 hours 18 minutes 25 seconds in 11 of January 2017. So the next is, since we already have the GMT time, we can now use this almanac pages to get the GHA and the LHA. So first, the latitude, which is provided in the scenario. So to get the GHA, we need to look the GMT time, which is 08 hours 18 minutes 25 seconds in January 11, 2017. So January 11, which is here, January 11 is here at 8 hours. January 11, 8 hours is here. So since we need to get the GHA of the sun, so we will look to the part of the sun. So this is now our GHA, which is 298 degrees 00.7 minutes, which is here. And now, since we still have to look for the increment, since it has 18 minutes 25 seconds. So to get that, we need to go to the increments pages of the almanac. So this is the increments at 18 minutes. So since it is 18 minutes here to 25 seconds, so 18 minutes 25 seconds is here. So we have the value of the increments, which is 4 degrees 36 minutes 36.3 minutes. So to get the total GHA, since we have no V correction on this part, so to get the total GHA we need to add this value. So 298 degrees 0.7 minutes plus 004 degrees 36.3 minutes. So we have the value of 302 degrees 37 minutes. So again, this is now the value of our total GHA. So since SHA is not applicable, so we will be looking now the LHA. So to get the LHA, I have here the formula. So to get the LHA, the formula is GHA plus east and minus west of longitude. So since our total GHA is 302 degrees 37 minutes plus, because it is in east longitude, so 123 degrees 53.0, 302 degrees 37 minutes plus east of 123 degrees 53.0 minutes. So since it is more than 360, so we need to subtract this value from 360 degrees. So we have here the value of our LHA, which is 66 degrees 30.0 minutes. So I have here the notes. So if LHA is 0 degrees to 180 degrees, name west. If 181 degrees to 360 degrees of LHA, named east. Since our LHA is 66 degrees, so it belongs to LHA 0 degrees to 180 degrees, so we will name it west. That is why our value of the LHA here is west 66 degrees 30.0 minutes. So we will now move on to the next page, which is we need to look for the declination of the sun. So to look for the declination of the sun, we need to go back to the first page of the almanac pages. So to get the declination of the sun, so again, we also need to look for the GMT time, which is January 11, 08 hours. So the value of the GMT time of 8 hours in January 11 is south 21 degrees 45.1 minutes, which I have written here. So this is the value of the declination of 8 hours in January 11. So since we have the D correction or the declination correction, we need to get this value, which is 0.4, to the increments. So since our the left value is 18 minutes 25 seconds, so we will look this value to this part because this is the 18 minutes. So to get this value, which is 0.4, the value of the correction is 0.1, which is, I have written here the 0.1. So now we will subtract if after we look the declination if it is decreasing, and we will add if it is increasing. So we will look to the declination since 45, 44, so it is in decreasing, so we need to subtract this correction to the actual value of the declination. So that is why I have this result. So 21 degrees 45.1 minutes subtracted to 00 degrees 00.1 minutes. So I have here the value of 21 degrees 45 minutes. That is our declination that I have written here. So now, to get the value of the ABC table, so first we will go to the ABC table. So this is the table A. So first, to look for the value of the table A, we will need the value of the local hour angle or our LHA and the latitude. So our latitude is 10 degrees and our LHA is 66 degrees. So to get the value, we need to look for the 10 degrees of latitude and 66 degrees of local hour angle. So this is our local hour angle, and this is the latitude. So I have here the value of 0.08, which is the value of our table, the value of our A, which is 0.08. So now to name that, I have here the note, name opposite to latitude except LHA is between 90 degrees to 270 degrees. So our latitude is in north direction, so we will name it opposite to the north, which is south, because our latitude does not fall to the LHA between 90, our LHA does not fall to between 90 degrees to 270 degrees, because our LHA is 66 degrees. So that is why the name of the value of A is south. So we will move to the value of B. So to go to the ABC table B. So to get the value of the B, so we need to look for the value of LHA again, and this time we need the declination. So our declination is south 21, and our local hour angle is 66. So 21 our declination, and the LHA is 66. So we have here the value of 0.42. So that is now the value of our B, or the value of our from ABC table, which is the B of 0.42. Now to name that is named same as the declination. So our declination named is south, so we have here the name south. Now to look for the value of C, we have here the note, if A and B has same name, plus if different names, subtract. So since since our A and B is in the same name, so we need to add. So 0.08 plus 0.42, we have here the value of 0.50. South, because they are in the same name. But if they are in different name, we need to get the names of which has the higher value. So now to get the true bearing, we just need to subtract this value from 360. So 87 degrees 12 minutes subtracted to 360 degrees, which we have here 272 degrees 48 minutes true. Now to get the gyro error, we have the given of bearing of the sun, which is 243 degrees from the scenario, 243 degrees true. And now we have the value of the true bearing, which is 272 degrees 48 minutes true. So to get the gyro error, to determine if it is high or low, they have here the note. If gyro bearing is greater than true bearing, then error is high. If lesser than error is low. So since our bearing of the sun, or our gyro bearing, is lesser than our true bearing, so we have here the gyro error as low. So that is for the first scenario. So now we will move on to the second scenario, which has the position of latitude north 10 degrees 19.0 minutes, longitude east 123 degrees 53.0 minutes, in December 1, 2017. Local time of 05 hours 20 minutes 21 seconds, and zone description is +8, so 8 hours ahead of the GMT. We took the planet Jupiter's bearing by gyro compass, observed bearings read 110 degrees true. Calculate for the true bearing and gyro compass error using ABC table. So first, we need to get the GMT time. So to get the GMT time of the ships in Jupiter, I have here the local time, which is 05 hours 20 minutes 21 seconds in December 1, 2017. and zone description of +8. So I have 8 hours ahead of the GMT. So to get the GMT, we need to subtract these 8 hours. So I have here the calculator. 05 subtracted to 8 hours, which result to -3 hours, and we need to add it to 24 hours to get the value of the GMT, which is 21 hours, 20 minutes, 21 seconds on November 30, 2017. So it is not December 1 in the Greenwich time. So to get the value of the GHA, so I have here, we need to also write the latitude which came from the given. So to get the value of the GHA of the Jupiter, we need to look into our almanac pages. So look for Jupiter, which is here, and look for the value of 21 hours on the day of 30, November 30, 21 hours. So this is now here the November 30. This is November 30, and in 21 hours, I have here the value of GHA, which is 165 degrees 58.5 minutes. So this is the value of the GHA. So this is the value of the GHA. Now to get the value of 20 minutes and 21 seconds, we need to go to the increments of the almanac pages. So we go to the increments of the almanac pages. Look for 20 minutes and 21 seconds. So this is here. This value here is 20 minutes. Look for 21 seconds, and we have here the value of 5 degrees 05.3 minutes. Look for the suns and planets value because Jupiter is the planet. So this is now the value here of 20 minutes and 1 seconds of 005 degrees 05.3 minutes. So we have also the correction of the GHA, the V correction, which is written here in the Jupiter section. So the V correction or the GHA correction is 2.0. So we need to look this value to the increments. Again, look for the 20 minutes and don't look to other minutes. So in 20 minutes, the value of the correction of 2.0 is 0.07. I mean 0 here. 2.0 is 0.7. So we can determine if we will add or subtract the correction if we will go back to the value of the GHA of Jupiter. So look for the value of the Jupiter. If it is increasing, we need to add. If it is decreasing, we need to subtract. So since it is decreasing, so 165, 181, so it is increasing, so we need to add this value, which resulted to 165 degrees 58.5 minutes added to 005 degrees 05.3 minutes added again to 00 degrees 00.7 minutes, which resulted to the value of total GHA of 171 degrees 04.5 minutes, which I have written in this part. So this is the value of the total GHA, and since SHA is not applicable, so we need to look to go to the LHA. To look for the LHA of Jupiter, I have here the formula. The formula is GHA plus if it is in eastern longitude and subtract if it is in western longitude. So since our longitude is east, so we need to add. So the total GHA of 171 degrees 04.5 minutes added to the longitude because it is east, 123 degrees 53.0 minutes, which resulted to 294 degrees 57 0.5 seconds or 30 seconds. So 294 degrees, 57.5 minutes is the value of our LHA. So 294 degrees, 57.5. So now we need to go to the next page to look for the value of the declination. So this is the value of the declination. Focus on this part because this is the Jupiter's part. So the declination of the Jupiter, to look for that value, we need again the almanac pages. So to look for the value of the declination of the Jupiter, which is in this Jupiter part, go to again the 21 minutes. I mean 21 hours because it is the hours in GMT. So 21 hours. So we have here the value of the declination, which is south 14 degrees, 10.3 minutes. So that is the value of our declination. Now we also have the correction. So the D corrections is for declination correction. So we have here the 0.2. To get the value of this declination correction, the D correction, you need to go to the increments. So look for the 20 minutes because it is the minutes in GMT. So in 20 minutes, the value of the 0.2 correction is 0.1. So now we can determine also if we will need to add or subtract our correction if the declination is increasing or decreasing. So since the declination is increasing because 10.3, 10.4, 10.6, so we need to add this value of correction. So this is, so south 14 degrees, 10.3 minutes added to 00 degrees, 0.1 minutes. So we have resulted to the value of south 14 degrees, 10.4 minutes. So now we already have the value of the declination. We can now look to the value of the LHA, I mean the ABC table. So go to our ABC table. First, we need to look for the value of A. So the value of A, again, we need to look for the LHA value and our latitude value here. So since our LHA is 294, our LHA is 294, so we need to focus on this part, 294. And our latitude is 10 degrees. Our latitude is 10 degrees, so this is the 10 degrees and our LHA is 294. So the value is 0.08. 0.08. So the value of our A is 0.08. So again, we have here the note, since our latitude is, since our LHA is 294 and it does not fall to the LHA between 90 degrees to 270 degrees. So we need to name our value of A opposite to the latitude. So the latitude is north. So the name of the value of A is south. So again, move forward to look for the value of B. Go to the ABC table. So to look for the value of B, I have here. So we need to look for the local hour angle again, which is 294, and the declination. Our declination value is south 14 degrees. So 14 degrees, this is the 14 degrees, and 294 of LHA. So this value here is the intersection. So the value of B is 0.27. which I have written here. So the name of the value of the B is name same as the declination. So our declination is south, the value of B is south. So again, to look for the value of C, if A and B has same name, add different names. subtract. Since in our scenario, we have arrived at the same name, so we need to add. So 0.08 plus 0.27. So we have the value of 0.35. And get the both name of this value, or the larger value, which is south again, because they are in the same name. So now, to get the azimuth, we need to go to our table C. So in table C, we need also to look for the value of our latitude and the value of the C. So the value of the C is 0.35, which is here, and the value of our latitude is 10 degrees. So since it has no 10 degrees here, so we need to get the lesser value, which is the 8 degrees latitude. So to get the value, it is here. So the intersection is the value of 70.9 degrees, or 70 degrees 54 minutes east. So to look for the direction, the azimuth is north or south depending on the name of the sea, and the east or west depending on the name of the value of the LHA. So the name of the sea is south, so our prefix here is in south. And since our LHA, so if LHA is between 180 and 360, so name east. If LHA is between 0 degrees to 180 degrees, name west. Since our LHA falls to the between 180 degrees and 360 degrees, so we need to name our azimuth suffix of east. So the azimuth value is south 70 degrees 54 minutes east. So to get this value, we need to subtract it from 360. So 70 degrees 54 minutes subtracted to 360 degrees, which resulted to again 70 degrees subtracted to 70 degrees 54 minutes subtracted to 360 degrees, which resulted to true bearing of 289 degrees 06 minutes through. So now to get the gyro error, so we have the bearing of the sun given, which the value of 110 degrees true, and our true bearing, which is 289 degrees 06 minutes through. So if the gyro bearing is greater than true bearing, the error is high. If lesser than, error is low. So since the gyro of the gyro bearing is lesser than the true bearing, so it is in, the gyro error is in low. That is for the second example. Now, for the third scenario, the position is same as the other scenario, and local time is 03 hours 32 minutes 57 seconds. Zone description is +8, so 8 hours ahead of the GMT. You took the stars Murphax bearing by gyro compass, observe 320 degrees true. Calculate for the true bearing and gyro compass error using ABC table again. So now we need to get the GMT time of the ship. So the GMT time of the ships is, we have here the local time of 03 degrees 32 minutes 57 seconds in December 5, 2017. So since the zone description is +8, so to get the GMT, we need to subtract the 8 to the local time. So 03 subtracted to 08, so we have resulted to -5 hours 32 minutes 57 seconds added to 24 hours, which the GMT time is 19 hours 32 minutes 57 seconds in 04 of December 2017. So now, to look for the value of the GHA, we also need our latitude and longitude. So to get the value of the GHA again, we need to get the we need to go to the almanac pages or consult the almanac pages. So the value of the GHA of star Merfax is, so here we need to go to the local time is 19 hours. So in December 4, 19 hours is here. So the GHA of Aries is 358 degrees 46.7 minutes. So it is here. And to get the value of 32 minutes 57 seconds, go to the increments again. Go to the increments again. So the increments is, so in 32 minutes 57 seconds. So this is the value in the increments, which is 8 degrees 14.3 minutes. So this is now the value in the increment. So to get the total GHA of Aries, we need to add this value. So 358 degrees 46.7 minutes added to 008 degrees 15.0 minutes. So since it is more than 360, we need to subtract it from 360 degrees. So you have the value of 007 degrees 01.7 minutes. So since it is in Aries, we need to get the value of the GHA of Merfax. So to get the GHA of Merfax, we need the SHA of the Merfax, which is, look for the almanac pages for the SHA and declination of Merfax. So this is Merfax. So the value of the declination is 308 degrees 35.5. I mean, the SHA is 30 degrees 35.5 minutes, which is here. So to get the GHA of Merfax, we need to add the value of the GHA of Aries and the SHA of Merfax. So the GHA of Aries is 0.7 degrees 007 degrees 01.7 minutes added to the value of the GHA or SHA of Merfax, which we have get here is 308 degrees 35.5 minutes added to the GHA of Aries, which is 007 degrees 01.7 minutes, which is, I mean, 007 degrees 01.7 added to 308 degrees 35.5 minutes, which resulted to the value of the GHA of Merfax, which is 315, which is 315.37.2. So this is the equivalent value. So increments 0.008 degrees and the total GHA is 007 degrees 01.7 minutes added to the star Merfax to get the total value of the GHA of the Merfax. So now the V correction is not available since the Aries has no V correction or the GHA correction. So to get the value of the LHA, we need our longitude. So the formula here is GHA plus minus or plus if east longitude and subtract if western longitude. So the value of the GHA is 315 degrees 37.2 minutes added to the value of longitude because it is east 123 degrees 53.0 minutes. You get our calculator. 315 degrees 37.2 minutes added to 123 degrees 53.0 minutes. So the result is 439 degrees 30 minutes 12 seconds. So since it is more than 360, we need to subtract it from 360 degrees, which gives us the value of LHA 79 degrees 30.2 minutes. So this is the value of the LHA. So we need to move to the second pages to get the value of the declination. So to get the value of the declination, we need to look for the Murphax star in the almanac pages. So the Murphax star again is here. So the declination value is north 49 degrees 55.4 seconds. Minutes. So this is the total value of the declination. So the declination of the Murphax is north 49 degrees 55.4 minutes. The correction is not applicable. So the total declination is this. So to look for the value of ABC, again, we need to go to the ABC table. So to look for the value of A, we need also the local hour angle, which is 79 degrees, and the value of the latitude, which is 10 degrees. So 79 degrees is somewhere here in this part, and 10 degrees is here. So the intersection is the value of the A in table A is 0.03 degrees, which is here. So to name that again, if opposite to the latitude, except LHA is between 90 to 270 degrees. Since our LHA does not fall to this part, so we need to name the value of the A to the opposite of the the opposite of latitude. So the value of our latitude is in north, so the value is latitude value is in north, so the value of this also is in south. So this is the value. So to get the value of the table, we go to the ABC table again. So look for the value of V. So to look for the value of V, we need our LHA, and now the declination. So the declination is 49 degrees and the LHA is 79 degrees. So this is the intersection. This is the intersection, which is the value of 1.17. The value of V is 1.17. So the value of B is named if A and B is named same as the declination. So our declination is north and the value of B will be north. So to get the value of C, we need to subtract if they are in. If A and B has same name, add, different name, subtract. So since our A and B is in different names, so we need to subtract 1.17 subtracted to 0.03, which resulted to 1.14 north, because the greater value is named north. So we need to get the name of the greater value. So now, to get the azimuth, we have to look for the table C. So to get the azimuth of the star Murphax, we need the value of the table, the value of the C, which is north 1.14, and the latitude, which is 10 degrees, since 10 degrees that must belong to here, so we need to get the lesser value. So the value is 41.5 degrees, or 41 degrees 30 minutes. So we need to name is as indicated in this part. So the suffix will depends to the name of the C. So the C is in north, the prefix will be north, and the suffix is in name if the LHA is between 180 degrees and 360 degrees. It will be named east and west if the LHA is between 0 degrees to 180 degrees. Since our LHA belongs to 0 degrees to 180 degrees, we need to name the suffix of the azimuth as west. So to get the value of the true bearing, again we need to subtract 360 subtracted to 41 degrees 30 minutes, which resulted to, 360 degrees subtracted to 41 degrees 30 minutes, which resulted to 318 degrees 30 minutes through. So we have the bearing of the Sturmer-Fox in the observation, which is 320 degrees through, and the true bearing is 318 degrees 30 minutes through. So to get the gyro error, we have here the note: if gyro bearing is greater than true bearing, then the error is high. If lesser, then the error is low. Since the gyro bearing is bigger than the true bearing, so the error is high. So this is how you solve or calculate the true bearing and gyro compass error using ABC table. So that is how you solve the gyro error and the true bearing using the ABC table, as an example of the Sun and the Jupiters and also the Sturmer-Fox. This is Decadetya Enrico. Thank you and God bless.